All right, here we go. Our home plate for tonight, pages 411 and 413 only. Bam. Pages 411 and 413 only. Also, the instructions on those two pages say blah, 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 whatever it says. What I want you to do is what I showed you today. The process that I show you today, I want you to do for those problems on those pages, not what the pages are asking you to do. Now, two of those problems, you're going to get stuck graphing them. I guarantee it. However, we have a nice tool that we can go to, especially those of you that have mobile phones or that you haven't taken it away by your parents. Go to Desmos.com. When you go to Desmos.com, press on the screen where it says Start Graphing. And then from there, over here on the window, just start typing the function that is given so you can graph the two functions that you're going to get stuck with. Does that make sense? So if it starts g of x, well, what are you going to type? G of x equals to whatever the case. Now check this out. Here's very important. Since we're dealing with rationals, that means something in the numerator and something in the denominator. Once you get started here typing your function, let's say I wanted to write x squared plus 5x plus 6 over x squared plus 2x plus 1. To write this in Desmos, you need to do this. G of x equals parentheses, then you do this, x squared plus 5x plus 6, close parentheses, forward slash, and then the second part, parentheses, yada, 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 yada. So like that, once you do this part with the parentheses and like that, it's going to change it to a fraction. Everybody with me? Yes, Mr. Q. All right, good. All right, let's move on. Our objective for today, I can write, solve, and graph rational functions. Today's our last lesson on this. We've had a lot of fun with it. Yeah, right? Yeah. And so today will be our last lesson before we move on to better things. Yes? Tell your neighbor the definition for rational functions. Rational functions are... Very good. Rational functions no. All right. Equations that contain at least one rational expression. Oh my goodness. All right. Also, just to take you back, I gave you the general rule for transformations, yes? And then from there we went to this. Is that correct? All right. And now we know how these two play a different role, H and K. Is that correct? They are what? Asymptotes. That is correct. Vertical and horizontal. All right. So let me take you on a quick trip back for the past 2 weeks that we've done rationals. Ready? Here we go. We started with, just pay attention, I'm going to fit the entire concepts in one slide, so pay attention. We started with f of x equals 1 over x. And I said, what does that graph look like? Well, it has an asymptote at 0, 0 for both x and y. And the graph is on the first quadrant and the third quadrant. Is that correct? So let me show it for folks that are watching the video. So here's my asymptotes, and this graph looks like this. Is that correct? Yeah. And there's my asymptotes. So that means, and I said, what happens if I give you a negative one? Tell you never what happens to the original one. Yeah, it just does the inverse, or it flips, right? It reflects about the x-axis or the horizontal asymptote. From there, I added a transformation. We went from here to here. Look at it. It takes the entire graph, the original graph, including the asymptotes, and it does something to it. Tell you never what it does.
It moves it.
Oh, very good. It moves it. What? Where does it move it to? 1 to the left. 1 to the left, because it's, what is the vertical asymptote? -1. So therefore, this one, what is the transformation? One to the left, and then what does it do to the graph? It reflects it or inverses, right? From there, I added more transformations. Look at this one. First of all, what does it do? 3 to the right and 5 up, and this one, all it does, it stretches it a little bit, okay? But the graph, we know it's in the same spot, we just move it around. And lastly, we got to these, and you're like, Mr. Q, that doesn't look the same. I know, but we have a polynomial over another polynomial. What did we do? Long division. And then at the end, we made it look like one of these. Is that correct? So, really quick. So, therefore, we can agree that the positive one looks like this. Is that correct? Yeah. And all the transformations, all it did is move the whole thing, asymptotes in the graph, to different spots and stretching some of those curves a little bit more than others. Negative ones is this one, and it reflected about the x-axis or the horizontal asymptote. And once again, with the different transformations, it moves the whole thing around on the coordinate plane. All right, from there, I said, let's crank it up a notch. We got 2 square roots on the denominator. And what did that one look like? It looked like a L and a J. Is that correct? Back to back. And then I said, but what if we have a negative? It reflects also about the x-axis or the horizontal. Then I added a transformation. Look at it. What does it do to the entire function? It moves it 2 steps to the right, because this is positive 2. Is that correct? Very good. And then from there, this one flips it. Is that correct? Because it's over the negative. From there, we went to these. Let's see the transformations. Can we leave the negative 2 in the numerator? No, it moves to the front, and that turns into a 1. Is that correct? So this is 3 steps to the right and 5 steps up, and since it's a negative, it reflects. Okay, so let's see those graphs. This is for my positive one, which is that one, and all these transformations, all I do is take all this and move it around, asymptotes and all. Negatives look like this. It's a reflection, same thing with the transformations, and moves it around. Are we there so far? And lastly, I said, let's crank it up a notch. And I said, let's get to these. So we got to these, and we saw that this denominator was not the same as these that are in parentheses. What did we do? We set them up equal to 0. We solved, and we ended up with 2 vertical asymptotes. And our graph looked like this. 2 asymptotes, 1 horizontal, and then we had our graph here, and then we had our parabola right there. From there, I say let's crank it up a notch. We already worked with vertical and horizontal asymptotes. Now we need to find what? The oblique or slant asymptote, which looks something like this. And how do we get that? We divided this by this, and whatever we got as a quotient, that was our slant asymptote. Okay? All right, well today we're going to get into more funner stuff. Yay! And it's going to look something like this. Check this out. We've been working with asymptotes. Are we there? Yes. Vertical, horizontal, and slant. The vertical asymptote is also known as discontinuity. It's called a discontinuity. Why is that, Mr. Q? Because if you sketch a vertical asymptote, a dotted line, and we start graphing our function from left to right, it discontinues, and it continues on the other side of the vertical asymptote. That's what's called a what? A discontinuity. So which one is that? The vertical one. However, the other discontinuity is going to be called holes or hole. You're saying, what does that mean, Mr. Q? Well, it's a hole. However, before I used to ask you to graph your function. Now I'm going to ask you to be specific with the point that's a hole, and then graph your function going through that part. And we're going to see that today. All right? Copy this one, please. Example 1. And it reads, rewrite the function and graph and identify asymptotes and holes. We got g of x equals x minus 3 over x squared minus 5x plus 6. Copy that. Not right now, just as is. All right. No. All right, here we go. So I'm going to go over this step by step. Just pay attention. I'm going to show you the process. This time I'm not giving you steps. You have to remember the process. I'm going to label each one, but you need to remember the process. I'm going to use different colors again so that you guys can see the process in the different steps. But I need you to stay focused. Here we go. Writing utensils down, look up to the screen. I'm going to zoom in. So they're asking me to rewrite the function and graph, and then from there identify the asymptotes or identify asymptotes and holes. Here we go. Okay, let me repeat that again. Eyes up on the screen. All right, here we go. Y'all ready? You guys ready? All right, here we go. Step 1. Don't copy the step. Tell your neighbor, what would we call step 1? That is correct. Factor all. Did I factor the numerator? Did I factor the denominator? Yes. Here goes step 2. Don't copy, just pay attention, please. You'll copy at the end. Here we go. Step 2. The first part you're like, oh, that makes sense. Giant 1. But this part might not make sense because this is what's new. We're going to set one of the factors because it's the same one denominator and numerator. Set it equal to 0, and that's how we get our x value for our whole. Step 3. And by the way, this is step 2. Step 3. What will we call step 3? Simplify or rewrite our new function. Because what was left right here? 1 over x minus 2. So that is step 3. Okay, hold on. Step 4. Step 4. The whole is actually a coordinate, an x and a y value. But right now I only have an x value. What can I do to find my y value? Substitute into my new function. That is correct. 1 over 3 minus 2, and that becomes 1 over 1, which is, this is the whole. Last but not least, step 5, or this is step 4. Step 5. Is there a constant here? No, so this is 0. Copy that, please. Woo, let's go. Once again, reminder, make sure you keep bringing your colored stuff, please. Here we good? Should be jamming by now. All right, so let's see. We should label this one step 5. So let me recap. Step 1, factor. Step 2, identify the giant 1 and take one of those factors, set it equal to 0, solve for x, and that's going to be the x value of the whole. Step 3, rewrite the remaining function. Step 4, I need to substitute the x value into the remaining function to find my y value of the whole. And step 5, identify what? The vertical asymptote and the horizontal asymptote. And of course, obviously, step 6 will be what? Graph. Let's go to graph. All right, here we go. So, let's start with our asymptotes. X equals 2. X equals 2 is right there. Y equals 0 is right there. All right. So before I sketch my graph, let's look at our function. Look at this one. It's 1 over x minus 2. So that means this graph is going to look like this. Look up. Like this. And like this. Do you agree? Yeah. So it's going to be here and here. But before I sketch it, I'm going to plot my hole. What is a hole? 3, 1. So I'm going to go to 3, 1, 3, 1. I'm going to sketch a hole right there. And now I can sketch this part of the function. You see what I'm saying? So since this function, it discontinues right here because it's only one hole that we found. So that means this side, is there going to be a hole over here, Mr. Q? No, the only hole that we found is what? 3, 1. This side will not have a hole. However, what do we know about all these points that they're reflected over here? Is that correct? So this one is 1 to the right and 1 up from this point right here where the asymptotes intersect. So that means 1 to the left and 1 down should be another point right here. But this one is a solid point. So my function goes through there. And that's what I want you to do for tonight's homework. Reflect the point, right, Kenzie? Yeah. Yes. They don't, because the whole is a discontinuity of the function. They do, because this one's a solid point. Yeah. All I'm doing is plotting a point so I can see the reflection of that point. Does everyone see my point? Now, I still have some of you that are a little bit confused. Look up really quick. Let me show you the reflection part. Here it goes. Write your utensils down, look up. So, does everyone see my vertical asymptote here at 2? Yes. And my horizontal at 0. There it is. But both of them intersect right here. Look up, right here and here. So that means this is my new point of origin. Are we there? So, which means if I was to ask you to plot me any point over here, let's say I picked this point right here, and I plotted a point there. According to where the two asymptotes intersect, this point is 1, 2, 3, 4 to the right, and 2 up. Let me repeat that again. From here, where they intersect, it's 1, 2, 3, 4 to the right, and 2 up. So if it reflects on the other side, obviously it has to be 1, 2, 3, 4 to the left, and 2 down, so that point reflected over here. Does that make sense? Yeah. That's really cute. We love these. All right, good. Kenzie, you good? All right. Joshua, you good over there? All right, good. All right. Let's look at the entire process. Step 1, what did we call this? Factor, all. Step 2, identify the giant 1, set one of the factors equal to 0, and we find the x value of the whole. Step 3, rewrite the rest of the function. That's our new function now. Step 4, substitute the x value into the new function and find our y value for the whole. Step 5, identify the asymptotes. And step 6, we graph. All right, copy this one. Example 1Q. I'm going to give you a head start for that one. See if you can do that one by yourself. We got g of x equals x plus 2 over x squared plus 3x plus 2. Copy that and go. All right, let's see. Check your work. Hands if you got -2, -1 for the whole. Yes, and our new function is g of x equals 1 over x plus 1. Our vertical asymptote, x equals -1, and horizontal, y equals 0. Yes? All right, let's graph that. Here we go. X equals -1. It goes through -1 of x. Y equals 0 is right there, so my horizontal is at the axis, so here it is. All right, let me plot the hole. The hole is at -2, -1. -2, -1, there's a hole right there. And my function going right there. So we need a point reflected on the other side. Tell you never the point that's reflected according to that hole to the other side. What's the coordinate? Let's see. Help us out, Damien. What? 1 to the right and 1 up. So what is the coordinate? 0, 1. That is correct. Show me the thermostat come to you out with this. 5 fours, 5 fours. Okay, we just need practice, right? That's what tonight you're going to practice. Yeah, let's do another one. But let's crank it up a little bit. But the process is the same. Here we go. Copy this one. Example 1 super cube. Yes. G of x equals x squared plus 7x plus 12 over x squared plus 4x. G of x, example 1 super cube, is g of x equals x squared plus 7x plus 12 over x squared plus 4x. Get us started, please, Ramon. G of x equals, what do we do for the step 1? 12 and 7. Factors of 12 that add up to 7. Man, your voice changed, Ramon. 3 and 4. That is correct. X plus 3, x plus 4. That'd be nice. Okay, and you're still not done, Ramon. Look at the denominator. It's not a trinomial, so what can we factor? X, that is correct. And that leaves us with x plus, and let's go. Pass someone? Kenzie, next step. Giant 1, x plus 4, and we write x plus 4 equal to 0, minus 4 minus 4. So our x value for the whole is -4. Pass someone, Kenzie? Ethan. So we write whatever's left, x plus 3 over x. What do you guys notice? Doesn't this look kind of funky? Is there a 1 on the numerator? No. So let's analyze what we have. We have a polynomial over another polynomial. What shall I do? Long division. Let's go. That is correct. X plus 3 over x. So let's see. What number times x gives me x? 1. 1 times x is x. I'm going to subtract, which means this makes this negative. This cancels. We're left with 3. That's our remainder. Is that correct? So my whole number is what? 1 plus remainder is 3 over x. Okay. It's almost looking kind of like what we used to write. However, now we switch the terms. Is that correct? So instead of 1 plus that, I'm going to write this plus 1. So I'm going to write 3 over x plus 1. We're almost there. Can we leave the 3 in the numerator? No. The 3 becomes what? 3 times 1, so 1 stays there. The 3 times goes in the front, so therefore our new function is g of x equals 3 times 1 over x plus 1. That is correct. Woo! Let's go. Kenzie, pass someone. Oh no, Ethan. Pass someone. Let's go. Then I get to pick someone afterwards. Let's go. So I already have my x value. Now I need a y value for the whole. Is that correct? So I write negative 4 here. What do I do with that? I substitute it into my new function. My new function is 3 times 1 over x. What is x now? Negative 4. And then at the end, plus 1. So far so good? So if I multiply the 3 times 1/4, that gives me what? 3/4, but it's a negative. Is that correct? So I'm going to write negative 3/4 plus 1. So if you have $1 and they take away 3/4, you're left with 25 cents or 1/4. There it is. I know, right? I just wanted to explain it to make sure people understood. So we're left with one last thing to identify our our vertical and horizontal asymptote. And I can pick anyone. Is that correct? All right, let's see. How about Josh? Go, Josh. Vertical asymptote. X equals? That is correct. Damn, because there's no number next to the x. Horizontal asymptote. Y equals what, Josh? 1 is correct because that's our constant. So now that we have all the components to graph this, let's see. Our vertical asymptote is 0, right there. Vertical, that means it goes straight up and down. Horizontal is at 1 of y, which is there. There it is. The whole for that function is at 4 and negative 4 and positive 1/4. Negative 4 and positive 1/4, so it's about right there. Focus, please. So my function is going through there. All right. However, we need to reflect this point to the other side. Josh, pick someone. Leo, let's see. This point, the whole, is according to this is where the asymptotes intersect. It's at 1, 2, 3, 4 steps to the left and 3/4 down. So where's my point on the other side? And that is correct. Let's go, Leo. And there it is. That's how we reflect those points. Show me your friends, how come you are with these? 4 5s, 4 5s. So he's over there like, peace, Mr. Q. All right. How are we doing? Okay, let's get another one started. Here we go. Copy this one. Example 1, super duper Q. Let's see how you do with that one. Example 1 super duper Q is g of x equals x squared plus 5x plus 4 over x squared plus x. Copy that and go. Who went last? Leo, pass the one. Michelle, what is the first step? Factor. So that means this one, factors of 4 that add up to 5. 1 and 4, so therefore get it, x plus 1, x plus 4, and the rest you know how to do. Anyways, your home plate for tonight, once again, it's Pages 411 and 413 only. Bam. There is tutoring, and it's free, by the way. Or make it a family math night. Go home and say, look what I learned today. Bam. See you guys tomorrow. Bye.